Hello and welcome, student, to this topic where we will discuss the first definition of the limits. So we have something, we call it limit, and usually we denote the limit by writing lim, and then you will see that we have a function f of x. It could be any type of function, and here down we need to tell you x approaches which number. For example, in this case, this one, we will say x approaches 2. Now, this has a meaning. Let's see in one example, what do we mean by this type of limit in the following example. Let's see example number 1. It says that how does the function, so we are given a function, behave at x equal to 1. So you have a function, and we are asking you how this function behave when x equal to 1. Let's see how things will happen. Well, the first thing is, let us try to substitute 1 directly. Let's see what will happen if we just, instead of x, we just plug in 1, which is the value that we are looking for the function to behave. Now, if we substitute 1, this will be 1, 1. Now, if you do it, this will be 0 over 0, and always 0 over 0 is not a number. This is an defined. So we cannot say anything exactly at x equal to 1. So what we will do, let us choose, now this is the other idea, let us try to substitute, not x equal to 1, substitute numbers that are closer to 1. Not exactly 1. 1, we know we get 0 over 0. Let's go ahead and check numbers that may be close to 1. Now, which number is close to 1? Yes, 1.1 is close to 1. 0.9 is close to 1. So let's try those numbers, and I think the best way is if we make a table. So I'll make a table here, a bit of a table. I will write values of x, and I will write the numbers that we should get. Remember, f of x, my function was x squared minus 1, x minus 1. Now, we know that at 1, it is undefined. I cannot plug in 1. Now, let me try 1.1. Now, if we have a calculator, if you substitute 1.1 here in this function, what you will get is 2.1. So the answer that you will receive is 2.1. Now, let me have another number which is close to 1, maybe 0.9. Now, this number, it will be, if we plug in with the calculator, 1.9. Now, let's choose another number that is even closer to 1. 1.1 is close, but maybe 1.01 is even closer. And by the way, 1.001 even closer and closer. Similarly here, 0.99 is even closer. And if we try even 9999, 4 nines even closer and closer. Now, let's fill this table. So plug in your calculator, write this as value for x, and write the answer here. If we do everything correctly, this will be 2.01, this will be 2.001, this will be 1.99, and this will be 1.9999. Now, what can you see in this table? Well, the more I close to 1 from the right, the answer looks like it goes to 2. And the same thing happened here. The more you get closer and closer and closer to 1, the number looks like it's close to 2. And this is why we say the limit is equal to 2. So just let me write this as a remark. We noticed that as x is closer to 1, or sometimes we say x is approaching 1, the function, which is f of x equal x squared minus 1, x minus 1, is closer to 2. That means, if we write it down, the limit of f of x as x goes to 1, the answer will be 2. So the behavior of this function near x equal to 1 should be 2. We cannot substitute directly, but that's how the sense of things. So if you take any x closer to 1 from any side, a little bit greater than 1 or a little bit smaller than 1, the answer, the function, the values you will get from the table will just get more and more next to 2. So I know that if I push, I cannot, for example, reach 1, but if I push a little bit very closely to 1, this is what you will get. And that's the idea, the whole idea of the limit of a function. So let's see example number 2. Example number 2, it says use the method of the previous example. What is the previous example? We need to make a table to find the following limit. So you have a function, it is f of x equal to x, and we need to make a table which we choose numbers that are close to 5, maybe a little bit greater than 5, a little bit less than 5, and let's see what will the behavior of the function will be. So if we say this is 5, this is x, and this is f of x equal to x. So if we just choose a number that is very small, and here we can choose 5.0001, 5.01. Now, of course, I don't care about 5 exactly for now. Let's see, if we just plug in 5 it will be the same numbers because the function is f of x equal to x. So whatever x up, I need to write it down. Now let's check the approach. If we go from this side, those numbers will go to 5. If I go from this side, this number also goes to 5, which means the limit as x goes to 5 of x will be exactly 5. That means substitute directly, x equal to 5 will give me an answer because I don't have 0 over 0. And that's example number 2, where we need to make the table. Of course, table method, we just do it once or twice. Later on, we will learn how to find the limit without using the table method. However, the table method is a good idea to give me what does the limit means in this term. Example number 3, I have a function which is piecewise function. It's written in 2 parts and I need to find the limit as x goes to 1. So what we will do, again, I'll do the table method up here. I need to choose number which are a little bit greater than 1. And then you have to choose a number which is almost 1 from the other side. However, my function has 2 options. If the number is greater than 1, you will need to use the second part, and you write the answer here. If the number x less than 1, you need to use this part. So let's start with the 0.99. So I'm asking you to use your calculator, find for me the value for 0.99. This is, we did it in pre-calculus. So which function we choose, the first or the second? Well, because it is 0.99, we have to choose the first because x is less than or equal to 1. So in the calculator, we multiply 5 by 0.99 minus 1. Whatever the number, we will write it down. It will be 3.95. Let me do it in a different color so that we can see. 3.95. And just let me write for you here is the red color here. Now, how about if it is 0.99? It will be 3.995. Now, how about if it's exactly 1? Substitute 1, it will be 4. Now, let's go to the second part, which is this one here. If x is greater than 1, so we have a little bit complicated situation here. So we have 1.01. The answer will be 4.9599. Now, if we do the same thing for 1.01, it will be 4.99599. Which means if we go through this path, the answer will be 4. However, if we go through this path, the answer will be 5. Now we have two answers. This cannot happen. So in this case, if we have two answers, one from the left, one from the right, in this case, we say that the limit does not exist. Unfortunately, we don't have a limit. So remember, if it's from different side, we give different answers. If it's greater than 1, we get 5. Less than 1, we get 4. That's not acceptable. We should have only one answer for the limit. However, the function, if we substitute 1, we get 4. That's we know. But as a limit, you have to check both sides. In the next example, we will start to find the limit without using the table. And we will use some kind of algebra. So we will need what you have learned in pre-calculus in order to do that.